Dr. Embalmer channel. So, as you might be aware, we have lately been doing some overclocking and chasing some world records for a GTX 950 and an AMD A10 7850K CPU. We reached and passed the world record. However, it turned out that for daily use, the overclock that we applied was not 100% stable. So after applying a full load on the CPU, the computer crashed eventually. I then lowered the CPU multiplier one step, and having run that for a week or so at full load, the PC was completely stable for that time. So seeing a difference like that after changing one thing usually means you've found the cause of the issue. However, lowering the CPU frequency, of course, yielded a lower score in 3D Mark when I tested that again to run Firestrike and TimeSpy. Not a whole lot, but around 75 to 100 points lower. However, I think it's worth the trade-off, because I would want to have a stable system for our further adventures with the test bench, which is running here, because otherwise, when we continue with our adventures of different kinds, if we get a crash, we don't know if it's caused by some recent setting change or because of an old overclock in the BIOS on the CPU, for instance, making it unstable in some scenarios. So we're trying to reach stability so that we can actually determine the cause of future crashes, which will eventually and inevitably happen, of course. Yeah, I did apply the last time a bit of a voltage increase. I believe it was a positive voltage offset on the V core by 50 millivolts. And now we're running about 4.3 gigahertz or so on the CPU. However, if we check the CPU temperatures, we seem to have a temperature of 91 degrees centigrade, that is, and with a full load applied. So perhaps that's not the best scenario for the CPU, and it limits our continued overclockability and being able to raise the voltage more. So I was thinking, digging around here, I thought, what would I be able to do about that? Well, the current cooler setup that I have is this, and it is a Noctua cooler It seems to have 5 heat pipes, if I'm not mistaken. We have a push-pull configuration with a chassis fan blowing air into the cooler, and then this fan helps pull air out of the cooler. There is also a bit of a worry with respect to the VRM, because the VRM on this board isn't the beefiest, and nor is the cooling of the VRM. So we have a VRM heatsink here, and currently it's warmer than finger warm, of course. Maybe it's about 60 degrees or so. But that's because I also do have a fan here sucking some cold air in from a window, and I can feel that, yeah, the air is cold and it's directed towards the motherboard. And so if I place my finger here, I can indeed feel a lot of airflow being circulated around this fin stack of this heatsink, which isn't enormous. So yeah, I noticed that I had 2 more Noctua coolers. One is of this kind, so also 5 heat pipes, and it's very similar to the cooler already installed, but it's not identical. So this one is perhaps a bit beefier. I'm not exactly sure what model it is. However, I found that I have an even beefier Noctua cooler, and if we compare them side by side, well, it's still a single tower cooler, but this beefier one only has 4 heat pipes, so we are losing 1 heat pipe, which you can see here. However, this one is, I believe, heavier. We should actually compare them, perhaps, and the weight. And also, we can see that the fin density is much lower on this beefier one, which might or might not be a problem. A higher fin density means more surface area if you have the same height of the cooler. But on the other hand, when you have these larger type of fans, you lose a bit of static pressure, and in that case a lower fin density will allow more air to pass through at a higher speed, which especially in a push-pull configuration should be able to transport a lot of heat away. So the question is this cooler better than the cooler on the right that's currently installed? Well, I believe that it's worth a try to change the cooler and see what kind of temperatures we get. So this has been running at full load for about at least 45 minutes, and we're pretty stable at 91 to 91.5 degrees Celsius. Another thing is, however, I'm not sure if the retention bracket will be the same for this cooler as for this one, because for this cooler I only have an Intel socket base plate. However, there are some spring-loaded screws here, which I hope will align with the spring-loaded screws and holes for the retention bracket of the cooler already installed. So yeah, why not try to change the cooler and see what kind of temperature, if any change, we get based on that. But let's do a weigh-in first and see what weight difference there is. Right, so here in front of me I have what probably isn't the most accurate scales that humanity has produced, but I believe that for these weights we have here, it will be good enough. I have left the base plates on for the moment, and the fans are also on. We only have one fan here and two fans here, so it's not an apples to apples comparison, but let's just place them on the scales and see, basically, as a first thing that we do. So the first one, the smaller cooler with 5 heat pipes, weighs in at 867 grams, which translates to 1 pound and 14.6 ounces. So 867 grams, okay. And if we place this one, 1059 grams, or 2 pounds and 5.3 ounces. So the difference isn't huge, especially considering we have an extra fan mounted here. So let me remove one of the fans. This is not the correct way of removing the fans, I suspect, but it will work for our purposes. These are very tightly on here. Right, so having removed one fan, let's try this again. So 885 grams, and I believe we had 886 on the other one. So the question is, let's see here, we have the same base plate basically, so 867, okay, 867, and this one 885. Yeah, so 806. Okay, so this is a little bit heavier with more mass, but it's not a whole lot. So actually I would like to do a weigh-in of this cooler currently mounted. So let's unmount that cooler first. I shall begin by turning off the power supply, and yeah, let's get to it. Alright, so I'm having a bit of trouble getting a good angle here, but let's start by removing the fans. So that we can access this one's a bit, yeah, now. So this fan was, let's see here, it was a Cougar CF V12HP. It has a bit of a dust that has collected. We can get rid of that later. But yeah, we basically have the same fan size on the beefier cooler as this one, so I believe this is a more higher power one. So this fan is, let's see here, .31 amps at 12 volts at full speed, and it does move a lot of air. The Noctua fan is only 0.09 amps, so 1.08 watts. So it's perhaps more quiet and more efficient, but I mean, in pure brute force, I would suspect this fan to be pushing more air. But with regard to static pressure, I'm not sure which one is better, but perhaps the Cougar one at higher RPMs will move more air and have a higher static pressure. So, but let's start by or continue by removing the second fan. Okay, so this Noctua fan, let's have a look at this one. This is the NF-F12 PWM, 0.6 watts, 0.05 amps. So this is a much more low power one than the fan on the beefier cooler. That doesn't automatically mean that it's better or worse, because things like blade design, blade count, angle of attack, and stuff like that matter a whole lot, of course, as well, for airflow and or static pressure. Alright, so the cooler is now ready to be unmounted, and I will unscrew it. hope that the base plate and the brackets already installed here will be the correct ones for installing the other cooler. Okay, we should be able to lift this off. And indeed. And this is what it looks like. We had a decent mount, I suspect. And let's have a closer look at the CPU itself. So this is what the socket looks like, and the CPU. That's better. So yeah, it's an interesting coverage here of the thermal paste, and it does seem to be a, let's see here. Oh, it's actually, the thermal paste isn't dry, at least. So that's good. Let's clean it up and do a weigh-in of the cooler that was installed here. And for this purpose I'm using some isopropyl alcohol and a bit of tissue. Like this, and it will nicely remove the thermal paste. It's still wet here, so okay, the CPU is pretty clean. Now I will also clean the base plate of the heatsink. See it evaporating here, the IPA, and now it's perfectly clean. All right, so let's do a new weigh-in of the cooler that was installed. All right. So, turning this on, $569, but we should add one fan that we had on the others. $737. Well, and a base plate, which isn't present on this one currently, because it's still stuck on the motherboard. But okay, so perhaps it's about 100 grams less. So in pounds, this is 1 pound and 10 ounces. Okay. So we should have we should be able to see an improvement of some kind going from this to any of these other two coolers, I would suspect. So the question is, which should we go for? The smaller one with 5 heat pipes, or the beefier one with 4 heat pipes. Yeah, I don't know. There's no clear winner for this, as far as I can tell. But let's choose the beefier one. It's funnier to go from a more compact one to a larger one. So let's do that. And we'll change the fans as well to the higher spinning ones, so we're moving a bit more air. So let's get started with that. So to be able to access these screws here, the spring-loaded ones, I will have to remove the fan as well, so I can access this screw here, which I will need for the AMD FM2 Plus socket. Okay, this is one. Let's remove it this way. Okay. So it does look like it's pretty clean. We'll have to remove the LGA Intel backplate first. Oh, maybe it's sufficient just to, yeah. Okay, so we don't have to remove those screws. These thumb screws, seems we don't have to remove them to be able to release it from the base plate. If I can just find the thread here. Yeah, so it should be enough just to release the spring-loaded screw a bit. Alright. Okay. That's good. How much does the base plate weigh? $109 grams, or 3.8 ounces. Okay. Right. So this has been freed. Let me just see if this one actually fits dimension-wise on the CPU socket. Okay, so placing it on top here. Are we getting mounted correctly? Let's see here. Yeah, the first one, this one, seems to be fine. How about the second one? It's a bit fiddly. Let me try this off camera. So unfortunately we are a bit out of luck here, because this overshoots the screw I have fastened it on the other side over here now, and in that case this screw is a bit off. Let's see if we can get a good view of that somehow. Yeah, you can see it's a bit too long. So that's no good. Let me unmount the cooler again. Yeah, so well, it did turn out that I wasn't able to use this beefier cooler, unfortunately, because of mounting issues and me lacking the correct retention brackets needed for this cooler to fit on an FM2 Plus socket. You can see the mounting mechanism is pretty different. So on this beefier cooler we have these brackets on the side, while the other coolers here, like the one that was present previously, is a bit different. It has like a bar that goes across the screw. So we do have a little bit of different spacing between the screws here, mounting screws. However, so let's unfortunately ignore this cooler at the moment and turn our attention to the other two. At first I thought that they are pretty identical, but in fact they're not. Because while having the same height and shape, they are they do look similar, although let's see here, yeah, almost the same length and width. The most noticeable difference becomes apparent when you flip them over. So here we have a much wider sort of a gap or blocked side than we have on this cooler that was installed previously. So it's a bit different design. I'm not sure which one is newer or better, but this was installed. So let's switch to this one and do that instead. Let's see what we get. And I will use the same fans and setup that I had previously. Well, maybe I will put the more high power Noctua one at least and see what we get. So let's get started. Alright, so let's just make sure that this fits. Yeah. Yeah, so these screws actually grip the threads, which is good. So this one should physically at least fit. Okay, great. So I will remove it once again, and we shall apply some thermal paste. Okay, and I will just give this surface a quick clean as well. All right. Some isopropyl alcohol. Get any oils and other impurities from fingerprints and stuff off. And maybe just giving the CPU a quick go as well. Okay. Great. So let's try to install it. So I have my syringe of NTH1 thermal paste from Noctua. Let's use that one. It hasn't been used in a while, so let me just extract the very first blob here, which might be a bit dry or so. Okay, and then let's place a dot there. This should squish out nicely. Right. Now I will basically place the cooler on top, like this. So both screws here on both sides have gone into position, and I will wiggle this a little bit just to squish out the paste side to side. And basically I'm going to start to screwing this down. And if I start with this one, I will first rotate the screwdriver counterclockwise until I hear a click, so that we have found the beginning of a thread. And then I do 1, 2 turns, and then I do the same thing on the other side. It's not visible on camera, but I go counterclockwise. I hear a distinctive click, meaning we found a thread, and then I go 1, 2. Then I go back here, and I go 1, 2, 3, and then I go back to the other side. 1, 2, 3. And this is to make sure we get an even mount. 2, 1, 2, 1, 2, 1, 2, 1, 2, 2. And then I do this until it stops. And this way we are applying pressure pretty evenly, on the CPU socket. So this side has stopped, and this should be, yeah, half a turn difference. So the mount is sturdy at least. Hopefully it's a good mount. And yeah, let's install the fans. So I'm wondering, what if we place the higher speed Cougar fan on the intake this time, because it's a more high power fan, so it should be able to push air into the fin stack. A bit better perhaps. And I'm wondering, can I use these brackets here, fan brackets, for this cooler? Let's give it a try, at least. So I want the fan cable to come out on this side, so maybe on top perhaps, so I get the brackets on the sides. But yeah, hang on a minute, we have a lot of dust here, so let me just give it a quick clean. Right, so a few seconds with a can of compressed air removed most of the dust, so this is good enough. And let's see here, we want this as intake now. Okay, so I will need it to be facing this way. So I have the fan brackets, but they are now turned the other way, so I have to remount these. Let's quickly do that. So let's see here, it should be this way perhaps then. Like this maybe, so it goes on this way. Hopefully that should work. Okay, let's give it a try. Sorry. Okay, maybe I blocked the camera a bit, but in the process. But yeah, this one seems to be mounted now. We can have a closer look. Oh no, maybe it's, yeah, but it seems to be mounted. And I can feel on the other side as well that it's sitting there in place. Great. So now for the second fan, and let's go with the 1.08 watt Noctua, the 90 milliamp version one. And this should be a bit faster spinning than the other fan that was on the old cooler, which was only 0.6 watts or something like that, 0.8 or 0.6. I will just grab the same fan brackets, as they are easier to install than the other ones. So one moment. And I also noticed another thing. The fan on the left has rubber grommets here, or rubber anti-vibration pads, which this fan doesn't have. So yeah, this was a 0.6 watt fan. So let's try to remove one of these. And oh, actually no, that won't work. We don't have the second hole on this fan. Okay, so let's forget about that, unfortunately then. But it's not a huge loss, I hope, in our case. Yes, okay. So this fan should be sucking air out of the cooler, so it should be facing this way. And if I want, well, yeah, the cable, it doesn't have to be too long, so it can pass on the bottom here like this. So let me grab, let me zoom out a little bit. See, does this? Oh, it's pretty tight here. I don't know. Will this actually? Yeah, maybe it fits this fan as well. And then the second one. These have a sort of pull tab. The other mounting brackets included with those fans were of this kind, and they don't have any pull tabs and such, so if this works, it is a lot easier to maintain. Okay, so let me try to install it. Okay, yeah, sure, it seems to be sitting on there, and yeah, mounting brackets seem to work for this as well, for this fan. So great. What's left now is to connect the fans. So I have them here. However, this one is a 3-pin one, and this one is a 4-pin one. But maybe that's okay. I have this adapter here, basically a Y splitter. It has 4 pins, but 3-pin will work, of course, as well. I don't know what voltage it will put out. It should be 12 volts if we are PWM controlled. Yeah. So this should be it. Let's turn the power supply on. and fire up the PC. Hopefully not fire, but you know what I mean. Basically turn it on. And I will just clean up the mess here on my bench, and I'll be with you in a moment. So the moment of truth is here. Let's push the button here and see what happens. Hopefully we will get display output and everything as well, but you never know. So this cable gets stuck in this fan. Alright, we have output. It's a start. Let's have a look at the state of things. Yep, we are having spinning fans. On both sides, and some airflow. Great. So let me log in. Okay, I will apply a load and see what kind of temperatures we get. All right. So let's have a look. We are at 4.3 gigahertz on all cores, and I have applied a full load on all cores. We have a 2 gigahertz north bridge clock. Utilization is 99%. And let's see here, 87 degrees so far, but we haven't been running this for a very long time yet. So it will be interesting to see where we land. I mean, we are at 89.1, although dipping to 86, 87, 88. Yeah, but I suspect it will need some time to finally reach a steady state. So I will let it run for a little while, and yeah, but basically we are at 90 degrees already. We had 91.4, I believe, 91.6 or so before. So yeah, I mean, we didn't really change the mass of the cooler or the surface area a whole lot, because we went from one cooler to the second one, which were almost identical. Not completely identical, but pretty much. We changed some fans, one fan, and the placement. So we are having the faster fan blowing air into the cooler. Previously it was blowing out of the cooler. And then we have a Noctua fan now blowing air out. Yeah, it feels a little warm, the air. and have a decent amount of air coming out here. Let's feel the VRMs are still cool, but we've only been running for a little while, so that's to be expected. And yeah, 90.3 degrees, 90.4. So maybe we didn't gain a whole lot. We replaced the thermal paste, so that is also a variable. The mount itself is a variable, so I still have a lot of variables that we haven't been able to isolate. But it seems to me, at least, at best we gained 1 degree of headroom, 1 degree Celsius, that is. And it won't really help us, perhaps, in trying to overclock this CPU any further with higher voltage, I'm afraid. But yeah, so I will let it run for a bit, and I'll see you in a moment. Okay, so this has been running for a little while, and yeah, the maximum we have seen is 90.8 degrees. So yeah, I mean, basically we are within 1 to 1.5 degrees lower than previously. 90.9 we got now. Okay, so yeah, it's not a huge difference, but that's to be expected considering the cooler change wasn't significant. But at least we changed the cooler, we changed the thermal paste, and that's pretty good as well. So yeah, great. So this will be the educational piece of today, on how to change a cooler and remove some thermal paste and stuff. And now you're up to speed on what's being done with the test bench here. But I'm curious to see in BIOS if there are any other changes we can do. But let's leave that for another day. So thank you so much for watching, and I will see you all in the next video. Bye bye.